Okay, so bear with us through this video, but this is our presentation. So this is the Biomechanics and Aerodynamics in Tennis, me, Rebecca Phelps. These are the articles that I referenced. It's the influence of ball velocity and court illumination on reaction time for tennis volley, as well as the pre and post impact muscle activation in the tennis volley that affects the ball speed, the ball size, and the side of the body. So these are some factors that affect tennis. The ball is the main factor. The outside forces such as air resistance, wind resistance, gravity, the court material and what the court's made of for the friction coefficient, also the racket and how it's strung and the grip, and the player. So the player is a big deal, and that's where the biomechanics come into play. So outside forces are, of course, gravity, air resistance, wind speed, air density, and the Magnus effect has a lot to do with these forces, and we'll get to that a little later. But as you can see, as the ball is moving through the air changes below and above, and it leaves some room for some forces here. Also, this is the center of gravity of the ball, so that's going to be affected as it moves through the air and as it hits the surface. Biomechanical influences on and from the player, so things can be acting on the player as well as the player can give force to the racket and the ball. So some factors are visual acuity. So how well can the player see, which has a major impact from the illumination of the court, how that's set up. Clothing and shoes are important. You don't want to wear cleats. Obviously, they'll scratch and grip the surface too much. You want to be able to move pretty fluidly back and forth in tennis. Clothing as well, you don't want clothes like this. You want clothes that will grip to you so that you're not increasing your surface area and moving slower. Also, your physical fitness, which improves your speed and agility. Your muscles are going to be activated for different strokes. Forehand, backhand, serve, all of these activate different muscles, and your physical fitness is a major part of that. As well as your reaction time and your hand-eye coordination, which also goes along with your physical fitness and your mental clarity. So you can improve upon these to improve your game. And like I said before, forehand and backhand muscle activation will affect the angles of the ball, as well as how it hits the surface and how fast it's going. So the influences from this on the player are going to be the vibrations from the racket. When the ball hits the racket, it's going to vibrate in order to have the equal and opposite reaction. We know that from Newton's law. So the opposite reaction is that it will vibrate towards the ball. When this happens, that is where biomechanical influences come into play for the person, because the vibration is going to affect the joints of the player, as well as their muscles. So we'll get to that a little bit later. Effects of the tennis court design, illumination is a big thing because that's going to play a major part in how well the player can see. Maintenance is a big deal as well. You see here these guys are actually removing a lot of debris from the court so that it can be smooth like this. You don't want a lot of cracks and a lot of glass or anything like that on the surface that can cause a lot of injury for the player. This is actually a resurfacing of a tennis court. They're laying down a lot of the materials that they use here. And you can see here these are different colors because these are actually different surfaces. So that's going to affect how the ball bounces on impact of the court. Okay, tennis rackets. Tennis racket and the tennis ball are just as important as the player. The tennis racket is actually going to be a double pendulum motion for overhead and serves and when it's connected with the player. So that's going to make a major difference for how you the ball trajectory. Is it going to go this way? Is it going to go this way? And your stroke will have a lot to do with that. The tennis racket itself is pretty important in how it's set up. They used to have only one-way strings, spaghetti strings, and they realized that that was actually making the ball go faster. And so for more challenge, we started cross-stringing. This is a sweet spot. This is where you kind of want the ball to hit for, straight angles. When you get around here and you get on the tip and stuff, you're going to put some spin on the ball. And spin is what is going to angle the ball. It's going to change its trajectory. It's going to change its angular velocity. And it's going to change its tangential velocity. So that has a major impact on the ball, is the spin. And the player with the racket is what's going to create the spin. This right here, the neck or the throat of the racket, is a lot of where the vibration comes in, where it's sent down to the grip. Now the grips are really important because that is what's going to affect how much vibration the player gets, and that's going to affect his elbow a lot. So if you have something like this where it's not really gripped very well, it's going to impact your game. You want something like this racket that's got a really good grip, it's been taped really nice, and the more grip that you have is going to add to the mass of the racket, which is going to decrease the vibration, which is also going to help in injury prevention. So grip is very important. Also, you see here that you can play with your right hand or your left hand, and that's actually going to impact the direction of how the ball spins. So if you're right-handed, it's going to hit this way, the spin's going to counteract, and the force of gravity is going to be this way. If you're left-handed, opposite. Forces and influences on the tennis racket itself. So, as I said before, combined with the force from the player and the factors influenced by the ball hitting the surface of the racket is used to create different angles of ball trajectory in the use of different strokes to create different types of spin trajectories, as I said. This in turn affects the velocity and the lift of the ball as it flies through the air to make contact with the court surface and the other player's racket. So as you can see here, when the ball hits the racket, it's going to make an angle. It's either going to go down and it's going to spin, or it's going to lift it up. Biomechanics of racket vibration frequency. So this is very important for the player. What does vibration frequency mean to you? When a ball hits a racket, the racket bends. The elastic force acts to restore the bent racket to its original position. But in doing so, the racket builds up momentum and overshoots its starting position. This action continues back and forth and is what we know as vibration, as I said before. The vibration will continue until the racket loses energy through internal friction and the dampening effect of squashing into the hand. To reduce this vibration, which affects the joints and muscles of the player, we use the grip tape to influence and increase the mass of the racket in order to decrease the vibrational frequency. Tennis ball. The tennis ball is the most important key to this whole game. So the tennis ball properties, you have 3 different kinds of tennis balls, 1, 2, and 3, and that's dependent upon the pressure that's in the ball and a little bit dealing with the diameter of the ball. So size 3 is a little bit bigger, and that's going to change the speed of the ball, and that's for people who are more advanced and they use a little more strength to hit that ball. It's a little more pressurized and it goes a little faster and it's a little bigger, so it's for a more challenged player. Also, the ball is, it has a rubber seam, which is going to affect the friction and the drag. And there's also a major difference in tennis ball than other balls, such as football, baseball, soccer ball, etc. A tennis ball has fuzz. And a fuzz factor is very important when it comes to tennis because the fuzz is what's going to create a drag through air resistance. It's also going to make contact with your strings, and it's going to help in the friction to create spin on the ball as it hits. The ball size is, the mass of it is around 57 grams. The size is between 2.5 to 3 inches, and it bounces by itself without a force, besides just regular force, up to about 58 inches. So as you can see in this picture here, the fuzz here is going to create a little drag in the air resistance, and it's going to flow through here, and it's going to go this way. As the ball gets older or more worn, the fuzz is going to change, and it's going to create a different type of drag. You always want to keep a smooth fuzz. Forces on the ball include surface tension and resistance from the impact to the court, as we said, angles manipulated by the racket and the spin put on the ball by the player, drag from the tennis ball fuzz factor, comparison of trajectories by changing the racket, the swing speeds, and your swing angles, as I said before, forehand, backhand, overhead serve, air resistance, wind speed, direction, and gravity, very important. Gravity is always going to pull that ball down. Force created from specified muscle activation of the player, like I said, swings. And the Magnus effect, tangential velocity, angular velocity, speed, and velocity are